Hi, welcome to Post Scholars, where we enhance learning through innovative methods. You have an opportunity to learn with Post Scholars now. Like, comment, and share.
So the title of this video is Converting Decimal Fraction from Base 10 to Other Bases, right? In our previous video, I taught you how to convert a number in base 10 to other bases. You might like to check it out. The purpose of this video is to prepare you for any examination question involving number base, particularly your JAM, WAEC, NECO, and other similar exams. Here in this video, we are going to solve 3 questions. So I would like you to pay attention closely while I solve the questions step by step. At the end of this video, you should be able to convert decimal fraction from base 10 to other base. So without wasting much time, let's solve. The first question says convert 0.625 base 10 to base 2, right? Now, whenever you want to convert a decimal fraction to other base, there's a rule you must follow. It says when converting a decimal fraction from base 10 to other bases, we simply multiply successively the decimal part by the required base. There are 2 keywords I need to explain: decimal part, decimal fraction, and decimal part. Now, what's a decimal fraction? For example, if you have 0.5, it's a decimal fraction. 0.25 is a decimal fraction, and let's say 2.5 is also a decimal fraction, right? Now 0.5 is a decimal fraction because it's still the same thing as 1 over 2. 0.25 is a decimal fraction because it's still the same thing as what? 1 over 4. And 2.5 is a decimal fraction which is still the same thing as what? 5 over 2. Now take note, 0.5 has 2 parts. I want to explain the decimal part now. I've explained the decimal fraction on its own. Now, it has 2 parts. The first part is what? 0. The first part is 0, which is the whole number part. And the second part is what? 0.5, which is the decimal part. When you add it, you have your 0.5. Similarly, 0.25 also have 2 parts. What's the first part? The first part is 0, and the second part, which is the decimal part, is what? 0.25. When you add it, you still have your 0.25. And 2 over 5 has 2 parts, right? The whole number part and the decimal part. The whole number part is 2, and the decimal part is 0.5. When you add it, you have 2.5, right? So let's solve the question. We want to convert 0.625 base 10 to base 2 quickly. Solution. Zero point 625 to base 2. The rule says multiply successively the decimal part by the required base. Now that we are dealing with the decimal part. Good. So the decimal part here, decimal part for 0.625 is what? Still 0.625. So multiply by the required base. The required base is 2. So 0.625 times 2. What do we have? We have 1.25. Now we are interested in the whole number part. We extract it, which is what? 1. Then the leftover, the decimal part for 1.25 is 0.25. So multiply successively again by saying 0.25 times the required base, which is 2. If you do this, you have 0.5. Now we are interested in the whole number part, which is 0. Similarly, the decimal part for 0.5 is still 0.5, right? Then successively we say 0.5 again times 2, and 0.5 times 2 gives what? That should be 1.0. The whole number part is 1, while the decimal part is what? 0.0, right? So we stop here because the decimal part is now 0.0. Now you present your answer. All the digits we extracted out, you count them or you write them from top to bottom. So we can now say 0.625 base 10, which is what we are trying to convert, is equal to 101 from top to bottom. 101. But remember, we are working with what? Decimal. We are changing decimal fraction to base 2. So since this one is in decimal, we will now have 0 point. I believe you understand why we put 0 point, because it's in decimal. This particular one is a decimal part. There's no whole number attached. The whole number attached here is 0, right? And 0 is not really significant like that. You understand? If it was 1 or 2, don't worry, we'll solve example based when here is more than 0. You'll see how it will look like. All right, so this is the final answer, 0.101 base 2. That's the final answer. Next question. Next question says, you can see this one now. Here is no longer 0, it's 568. So we want to convert 568.211 base 10 to duodecimal. Quickly, question 2. Want to convert 568.211 base 10 to duodecimal. Take note, duodecimal. Where's the question? Duodecimal here means base 12. It means base 12. Take note of that. Right? So want to convert 568.211 to base 12. Duodecimal and base 12 mean the same thing. Now we have two parts here, like I was saying. We have the whole number part. For this 568.1, we have the whole number part, which is 568, right? Plus the decimal part, which is what? 0.211. So what we'll do is we'll first of all convert 568 to base 12, then we convert 0.211 to what? Base 12, then we combine it together. So let's start. First step. So converting 568 to base 12, you know how to do that now. You want to convert 568 base 10. Remember, they are both in base 10. Want to convert 568 base 10 to base 12. So you divide by 12 successively and write out the remainder. How many 12 can you find in 568? 47. Remainder 4. How many 12 can you find in 47? That's 3. Remainder 11. Now take notes. When counting in base 12, because we want to convert to base 12, this is how we count in base 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Instead of writing 10, you now say A, B, and C. So this is how we count in base 12, right? Then A represents what? 10. B represents 11. And C represents 12. Are you following? Good. Now, that means this your 11 means what? B. So we continue. How many 12 can you find in 3? 0, remainder 3. Now to present your answer, you write out all these digits. You write them out from bottom to top. Take notes from bottom to top. Write them out from bottom to top. So writing it out, you can now say 568 base 10 is equal to 3B4, right? 3B4 base 12, right? Now that's the first step. What's the second step? Second step, Second step, the decimal part, we have to convert it to what? To base 12. I taught you how to do that. So we want to convert 0.211 in base 10 to base 12, right? And the principle is clear. Whenever you're converting decimal fraction to any base, what do? We simply multiply successively the decimal part by the required base. So here, the decimal part for 0.211 is already 0.211. So we say 0.211 times 12. When you multiply it, what will you have? You have 2.532. So we are interested in the whole part, which is 2. Right? Next, the decimal part for 2.532 is 0.532. So we say 0.532 times 12 again. What do we have? We have 6.384. So we are interested in the whole part, which is 6. Next, the decimal part for 6.384 is 0.384. So multiply by the required base times 12 is equal to, that's, if you multiply it, you have 4.608. So we are interested in the whole part, which is 4. Then again, the decimal part for 4.608 is 0.608. So we say 0.608 times the required base 12 again. When you multiply that, you have 7.296, right? So we are interested in the whole part, which is what? 7, right? Again, the decimal part for 7.296 is 0.296. Then multiply by the required base times 12. What do we have? We have 3.552. So we are interested in what? The whole number part, which is what? 3. Now, looking at this, you will see that the all the number we are extracting out, it won't terminate, right? It's called a recurring fraction or recurring decimal. You understand? So we'll just stop here because you can continue up to infinity. So let's just stop here. So how do you present your answer? You will now say, remember, this is the focus. This is what we want to convert. You now say 0.211 base 10 is now equal to, you write it from top to bottom. Write out the extracted digit from top to bottom, unlike this one, right? I hope you know the difference. Good. So writing it out from top to bottom becomes 26473. That's 2. Sorry, remember, that has to be 0.26473, right? Base 12, converted into base 12. Now you can now present your answer finally. So what's the major question? The major question is 568.211. So you can now say 568.211 base 10 is equals to, what do we get for the whole number part? The whole number part, we got 3b4, right? So 3b4, right? Then plus, take notes, the decimal part is this. What do we get? We got what? 0.26473. So combining it together, what do we have? We have 3b4.26473 base 12. So that'll be your final answer. Next, we'll move to the third question, which is the last question for today's video. This particular question says, convert 5 whole number 7/8 to decimal. Take note, decimal also mean base 2. But the reason why we use decimal is because we are working with what? Decimal fraction. So without any further ado, let's jump into solving the question right away. 5 whole number 7/8, that's question 3. Question 3 says, convert 5 whole number 7 over 8. 5 whole number 7 over 8. All in base 10 to base to decimal, which is the same thing as base 2. I told you before. Now looking at this, 5 whole number 7 over 8. Take note, it's called a mixed fraction. You know, we have three kinds of fraction: mixed fraction, proper fraction, improper fraction. So this is a mixed fraction, which combines the whole number and the decimal word and the fraction, yes, or decimal fraction, right? So we need to do this very well. So if you solve this, you have 5 plus 7 over 8 is still the same thing as 0.875. 0.875, right? So that when you add it together, you now have what? This is in base 10, please. When you add it together, you now have 5.875. So this is what we want to convert to base 2, right? So before we do this, what do? We split it into what? The whole part and the decimal part, right? So 5.875 is still the same thing as 5 plus what? The decimal part 0.875. So the first step, we convert base 5. We convert 5 and base 10 to base 2, and we convert 0.875 base 10 to base 2. So the first step now, to convert 5 to base 2, simply divide it by 2. So how many 5 can you find in 2? You have 2 remainder 1. How many 2 can you find in 2? That's 1 remainder 0. How many 2 can you find in 1? That's 0 remainder 1. So to present your answer, you just say 5 base 10 is equals to, count from bottom to top. That's 101 base 2. That's the first step. The next step now is to convert this one to base 2. So 0 points. Second step, I want to convert 0 point what? 875 base 10 to base 2. Now what do? You simply multiply the decimal part by the required base, right? As you already know, the decimal part here is 0.75. Still the same thing. So we'll say 0.875 times what's the required base? 2. What do we have? We have 1.75, right? Then we extract the whole parts, which is 1. The decimal part is 0.75, right? So again, we'll say 0.75 times the required base, which is 2, equals, when you multiply 0.75 times 2, you have 1.5. So you extract the whole parts, which is 1. The decimal part here is 0.5, right? So you say 0.5 times 2. And 0.5 times 2 gives you what? It gives you 1.0. So the whole part is 1, which is what we need. Then the decimal part again is what? 0.0. So you stop here because you've gotten to 0, right? So it's now 0. How do you present your answer? You present your answer by saying, what's the major question? Major question is this: 0.875 base 10 is equals to, now you write out the digit from top to bottom, 111. That's 0.111 base 2. The next thing to do is to present your answer finally. Remember the question. The question says convert 5 whole number 7 over 8 to base 2. So 5 whole number 7 over 8 base 10 is now equal to, what's the whole number part? The whole number part is 101 base 2, right? 101 plus, what's the decimal part? The decimal part is what? This is it here. 0.111 plus 0.111. So our final answer becomes 101.111 base 2. And that is the final answer. So, having solved these three questions, I want to believe that you should be able to convert any decimal fraction from base 10 to other base. Thank you for watching, and I'm expecting you in the next video. Bye.